Alright, so this is one of a few revision sessions, and we intend on starting with some basic concepts and we will work our way up. So now the initial topics would have been fractions, decimals, so fractions, decimals, and let's factor in order, order of operations. So we will look to start with these three topics for today's session, and come next week we will move into transposition and some algebra. Alright, so fractions, and you're all seeing my screen clearly, right?
Yes, sir.
So a fraction is commonly represented using three parts. So the top part up here is what we refer to as the numerator, denominator, and what do we refer to this line as? Fraction bar or vinculum. So these would be the three parts of your typical fraction, and what this tells us is that the numerator is being divided by the denominator. So that's what's happening inside of a fraction. Alright, so we have several types of fractions. And what are they?
Mixed fraction.
What other one?
Circles or improper fractions.
And what's the last one? Proper fractions. So these are the three main types of fractions that you will encounter. So now a proper fraction is one where the numerator is smaller than the denominator. Who can give me an example of that?
3/5.
Which other one?
1/2.
And let's say 4/9. So all of these would be proper fractions because the numerator is smaller than the denominator. So now we have improper. And the characteristic for an improper fraction is that the numerator is larger than the denominator. Some examples of this would be 8/3, 2/. So these would be examples of improper fraction. So a mixed fraction so this is a combination of a proper fraction and a whole number. So who can tell me which operation? So it says a mixed fraction is a combination of a proper and a whole number. So who can tell me which operation is taking place over here? So with the whole number and the proper fraction, which operation is taking place? Addition. So for example, this one right here, this is saying to us that it is 3 plus a half, right?
Yes, sir.
And 3 plus a half, so 3 would be the same thing as 6/2 plus 1/2, and this would give us 7/2. So if we were to change this to an improper fraction, we'd get the same 7/2. 2 times 3 equals 6. 6 plus 1, 7/2. So that's how it works. That's why we're able to say denominator times the whole number, then we add the numerator to get this the numerator for the improper fraction here. That's what's happening when going from a mixed fraction to an improper fraction. So we're going to look at a few examples of that. Don't worry, it will get harder. Right, Hannah?
Okay, sir.
I know you're looking and you're saying, "I really this sir I have class for?"
No, no, no. I'm not saying no.
Alright, so going from a mixed to an improper fraction. So let's say we had 3 and 3 over 4. And we wanted to convert this to an improper fraction. What would we do?
We multiply the whole number, which is a 3, by the denominator 4, and then you add that value that you get with the numerator, which is 3. So 3 4s 12, and 12 plus 3, 12, 13, 14, 15, so 15 over 4. 3 4 are 12, right?
Yes, it is 15 over 4. Is everyone clear with this? So these are the very basics. Nothing too complicated as yet. We should be able to look at them and know the answer. For example, if I say, alright, negative 3 and 1 over 6, this would be equal to what? What's that one?
Negative 17 over 6.
No. Any other takers?
I guess 18 over 6.
Mm-mm.
90, sorry.
19 over 6?
Yeah. Would it be a negative 19 over 6?
So yeah, it would be negative 19 over 6. So why did this one take so long?
Sir, me get negative 7.
How did you get negative 17?
Negative 3 times 6, 18, plus 1 over 6. That's right, sir.
Alright, so this is where a common misconception occurs. So what's happening is that this negative sign at the front, we should ignore that completely first. So we have to ignore this negative sign first, and then we operate with it normally. Then after we're finished, we put back the negative sign. If you work it with the negative sign, you're going to get negative 17 over 6. Let's look at negative 17 over 6. If we have negative 17 over 6, how do we convert from an improper fraction to a mixed fraction? We simply divide the numerator by the denominator, right? And put the remainder over denominator. So what is 17 divided by 6? How many times can it go into that?
3.
How many times can 6 go into 17?
3.
Who is saying 3? So it's 2. And what's the remainder? So is this the same thing as this? So we can't look at it like that. If we're working from a mixed fraction to an improper, we have to ignore the negative sign.
But sir,
Yes?
we get negative 2 or 5/6. I'm confused.
Yeah, that's what we would have gotten if we had negative 17/6. But we don't have this is the answer.
Oh, okay.
So I'm saying whenever you're working with a mixed fraction with a negative sign in front of it, you have to ignore the negative sign first. Alright, try this one. Negative 5 and 2/7. Convert that to an improper fraction.
Negative 37/7.
How did you get that?
The 5 times the 7, 35 plus the 2, 37, and go back to negative.
So 5 times the 7. So we're completely ignoring the negative sign, Kai. We're pretending as if there is no negative sign there. So it's 5 times the 7 plus the 2. So 5 times 7, that's 35 plus 2, 37. Put back over 7. And then once we get that, we should remember that there was a negative sign here. We simply put it at the front.
So I got that.
Alright, so one last one. Let's say negative 9 and 1/9.
Sir, negative 81/9.
Sure?
No, sir, it is negative 82/9.
Negative 82/9. So the procedure is pretty much similar to working with all positives. The only thing is that we need to ignore a negative sign, do the same operation, put by the negative sign, that's all. And that's when going from a mixed fraction to an improper fraction. So now let's look at the opposite, going from an improper to a mixed fraction. Alright, so let's say we had 27/8 as our starting point, and we needed to get to a mixed fraction from this, or we need to get a mixed fraction from this. So what's happening is that we need to find how many sets of 8 we can get from 27. That's what this is saying to us. How many times can we get 8 out of 27? So this is 27 divided by 8, and that's asking how many times can we get 8 out of 27. That's what it's asking. Alright, so how many 8s are there in 27? So we can get 8 3 times from 27. But if we say 8 times 3, that's not 27, that's 24. So what do we do with the remainder?
Put it as the numerator. So it'll be 3 and 3 over 8.
Wait, what is voice to sound like one of my students? The voice here sound like someone. So it's 24 and the remainder would be 3. So the answer we get from that is 3 and 3 over 8. And this would be its mixed fraction form. So we're going to try 2 of this and then we jump into some addition, subtraction, multiplication and division. And then we will get into some of those tougher questions. Alright, so try these. We're given 52 over 7, 43 over 11, negative 74 over 13, and 36 over 5. And we need to convert each of these to a mixed fraction.
You want the answer for number 1?
Sure.
7 and 3 over 7.
So number 2 is 3 and 10 over 11, I think.
Number 3.
So for number 3, I got negative 5 and 9 over 13.
And the last one.
Seven and 1 over 5.
Alright, very good.
So I have a question.
Sure.
So for number 3, I don't understand how to get 9 because I'm getting 7.
So you'd say 13 into 74, or how many 13s we can get from 74, and that would be 5. Because
Yes, I understand that, but my calculator is like telling me a decimal and I get 5 and 6, 9. Isn't that round up to 7?
no, you're looking at it wrong. You see, when you get when you find out that it's 5 times, you should say 5 times 13. So 5 times 13 would give you 65, right? So we need to see what's the remainder here. 74 subtract 65, that would be the remainder. So 74 subtract 65 would leave us with 9. So that's how we got the 9 right here. So we figured out that it's 5 times would give us 65, and then we need 9 more to get to the 74. So that's why we have a remainder of 9 over 13.
Okay, sir.
Alright, so now we have addition and subtraction of fractions. Alright, so there are two different conditions or two different ways we can look at addition and subtraction. One is when we have like denominators, and when we have unlike denominators. So for like denominators, the procedure is just adding the numerators. And for unlike denominators, we need to find what we call the LCM, or lowest common multiple. Alright, so quick maths. And so we have 4 over 5 plus 7 over 5. That results in
11 over 5.
11 over 5. We simply add the numerator. So that's example 1. So now let's say we have 3 over 7 minus 9. Let's not make that 9. Let's say 10 over 7. What's our answer?
7 over 7.
Negative 1.
So me here 7 over 7 and me here negative 1.
Sir, don't listen to me.
Have faith in yourself, guy. So here it will be 3 minus 10. So that would be negative 7 over 7. However, this can be simplified as negative 1. Alright, easy stuff. Alright, let's say we have 1 over 2 plus 3 over 5.
Sir, add 1 and 1 over 10 or 11 over 10.
Did anyone else get 11 over 10? Anyone else with 11 over 10? Yes, no, maybe.
No, sir.
Alright, so Tori, would you be so kind to explain to us how you got 11 over 10?
So, sir, I found the LCM, which was 10.
So
And then
how did you find the LCM as 10?
I multiplied the two denominators and got 10. And so because
you have to multiply the 2 by 5. You also put whatever you do to the denominator, you do to the numerator. So it also multiply the 1 by 5. And since you have to multiply the 5 by 2, you multiply the 3 by 2. So the 1 times 5 will give you 5, and the 3 times 2 will give you 6. And when you add the 5 and the 6, you get 11. And that's how I got 11 over 10.
So you're basically saying 2 into 10 goes 5 times. 5 into 10 goes 2 times. And that's how we get the 11 over 10. Following, Kai?
Yes, sir.
Alright, let's shake things up a bit.
No, sir, why you delete it?
Now I'm going to send this document, and the recording as well.
Okay.
Alright, so let's say we have, let's make things a little bit more interesting. 3 and 1 over 7 minus 2 and 1 over 4 plus 1 and 1 over 3. What do we do in this case?
So you turn them into improper fractions.
So the first thing we need to do is to convert all of these to improper fractions. Alright, so I'm going to, I can't see who is online. So just give me the improper fraction equivalent of these.
$22 over 7.
Minus
9 over 4.
plus
4 over 3.
So what would our LCM be? What's the LCM?
Sir, I'm not find the else.
Sir, 21.
No, it's not 21. We can't get a 4 out of the 21.
34.
84. It's not 84 either.
$64.
How do we find LCM?
Find the lowest number that the numbers can go into without the denominator.
Wait, what did you say a while ago for your LCM, Tori?
I was just saying that you find the lowest number that.
No, what was the LCM you gave?
Sir, no.
Oh, the LCM I gave was 84.
Oh, yeah, it's 84. So what happened is that she multiplied the 7 and the 4 and the 3. That's 84, right? 7 times 4 times 3. Yeah, that's 84. So the LCM would be 84.
So that's all you need to do.
Yes, but not all the time. You don't need to do it all the time, because sometimes, let's say we had something like this: 5 over 2 plus 7 over 4 plus 3 over 10. Let's say we had something like this and we wanted to find the LCM. One would say that we're going to multiply all three of these numbers down here to get the LCM. So if we say 2 times 4 times 10, what's that?
80.
80. But if we look at this, there are smaller numbers that 2, 4, and 10 can go into, all three of these numbers. And what would that number be?
Say 40.
There is a smaller one.
Smaller than what? Say 40.
I'm saying there's a smaller one than 40 that all three of these can go into. 20. So there's a little trick to it. It's not really that big of a deal, you know, because we could have worked with 80 here, so, and then whatever answer we get, we simplify it and we get the answer and move on. So it's not really that big of a deal per se to stress about, because whatever number we use as the LCM, as long as all three of these can go into it, we can simplify the answer in the end, whatever answer we get. So now let's say 7 into 84, 12 times, 22 times 12, that's what, 220, 242, no, 220, 264, yeah. Four into that, 21, 9 times 21, 189. 3 into that goes 28. 4 times 28, that's 112.
112.
Yeah. Alright, adding up all of this, 376, 276, 100 and, what do you get? 100 and something? 187. 187 over 84. And can this be simplified? Can it be simplified?
In a mixed fraction?
No, that's not simplifying. Simplifying would be reducing this fraction as is. Changing it to a mixed fraction isn't classified as simplifying.
No, sir.
So this would be the final answer. Alright, so let's speed run one more. And for this one, I'm giving you 3 minutes. So you're going to evaluate the following: 2 and a quarter plus 3 and 1/3 minus 1 and 4/5. So for this one you have 3 minutes. And I don't want any calculator to solve it, or just to put everything in the calculator and solve it, because on your mock exam I think I will specifically state that you should show the working. Alright, your time is up. Did anyone arrive at the answer?
No, sir, I'm not done. 227 over 60.
227 over 60. Alright. Any other answers?
So 227 over 60.
Alright, so getting the same answer twice, so that means it's right? Right?
Yes, sir.
Alright, let's see. So converting all of these to improper fractions, this would be 9 over 4 plus 10 over 3 minus LCM 60 135 so that's 335, 235, 227. And is that the final answer? Can it be simplified?
No, sir.
No, sir.
Alright, very good. So that's how we would approach these kind of complex but not too complex questions. And when we get to multiplication and division, we're going to be combining everything: addition, subtraction, multiplication, division in one question, similar to those that you would see on the past paper. Alright, so multiplication and division of fractions, which is even easier than addition and subtraction. Alright, so when multiplying, we multiply numerator by numerator, denominator by denominator. So let's say we had 1 over 3 times 4 over 5. This would give us a result of what?
4 over 15.
So numerator by numerator, denominator by denominator. That's how we do it. Alright, so that's a basic one. How about 7 over 9 times 3 over 7?
21 over 63.
Which would be
3 over 9.
go again.
1 over 3.
1 over 3. So the idea behind these types of multiplication is that when looking at the original question, we notice that some of these share common factors. For example, 7 and 7 here, those can be cancelled. Then we have 3 and 9. 3 into itself 1 time, 3 into 9 3 times. So we could have gotten to the answer before even multiplying numerator by numerator, denominator by denominator. So that's one approach we can take when multiplying fractions. We look if there is anything common or any common factors in the numerator and common factors in the denominator. Well, a common factor or a shared factor from an element in the numerator with one in the denominator. So how about this one? 51 over 60. Let's see. 76 times 4 over 12. Without multiplying top by top, bottom by bottom, can this be simplified before?
The 4 and the 76.
So 4 into itself 1 time, 4 into 76 19 times. Anything else?
No. Sir, the 51 and the 12 by 3.
So 3 into 12
Oh.
4, and 3 into 51
17.
So this would be 17 over 76, and that would be your answer. So looking at multiplication of fractions, we should be able to recognize these things. If we can't easily recognize it, we can just do it the default way, multiply across, and then we try and pick out the common factor that we can cancel. Is that clear?
Yes, sir.
Alright, so division. Let's say we're looking at 2 over 5 divided by 1 and 1 over 8. How do we do such a division?
Change the sign to multiplication.
And then what?
Flip
What do we flip?
1
So-
over 8.
But this is not 1 over 8. This is 1 and 1 over 8.
Sir, would you change it to improper first, then change the division to multiplication?
So we must first change this to improper. So remember, whenever we are dealing with questions that involves mixed fraction, we must change them to improper fractions first. So changing 1 and 1 over 8 as an improper fraction, what do we get?
Nine over 8.
9 over 8.
9 over 8. And Now we have two fractions, one proper and one improper, and we need to divide them. So we keep the first fraction, we change the sign. What do we change the sign to?
Multiplication.
And we flip the second fraction. So now what we're going to have is 2 over 5 times 8 over 9. And can anything be simplified?
No.
So if nothing can be simplified, we simply multiply across. So it's 2 times 8, 16. 5 times 9, 45. And that would be your answer. And that's the simple procedure behind dividing fractions. So now we want to look at a few past paper questions that would involve fractions. So this one says using a calculator or otherwise calculate so it's 1 and 4 over 5 minus 1 over 3 over 2 and 2 over 5. Alright, so look at this. So this is a past paper question and they want us to calculate the exact value. So what does exact here mean?
The final value.
Yeah, but they said exact. Why did they put this exact in all caps?
Because it's supposed to be a whole number.
No,
Simplified.
not just simplified. Whenever we see exact value, it means that they want us, especially working with fractions question, they want us to leave the answer as a fraction. So don't go ahead and convert the people in fraction to decimals. So leave answer as a fraction. So how do we approach such a question? How do we start this question?
Change the mixed fraction into
Alright, so that's the first thing we need to do. Whenever we're doing fractions question and there are mixed fractions, we need to convert all of them to improper fractions first before we do anything else. Alright, so we're rewriting this. And that's going to be what? What's the numerator?
9 over 5.
9 over
9. 5.
denominator.
12 over 5.
Alright, so we have strictly proper and improper fraction in our question. What do we do next?
Subtract the 1 the 9 over 5 minus 1 over 3.
So we operate with the top part of this question first. Seeing that we can get a final answer for the numerator here, we will do that. So we're going to write 9 over 5 minus 1 over 3. Now looking at this, these aren't like denominators, so what do we need to find?
LCM.
And the LCM would be,
15.
so 5 into 15, 3 9 27. So that's 22 over 15. So I don't want you to just give me this as the answer and say, alright, that's the answer. Remember, we have another part of the question. We're not finished as yet. So this is just the numerator. This part right here, and let me do it the other way. This part right here is just the numerator. So now we need to find or rewrite what we have. So this is equal to 22 over 15 over 12 over 5. So what is happening here? So we see a fraction in the numerator over another fraction. What is this saying? I didn't get that. Still not hearing.
So you're transposing.
We can't transpose. We don't have anything on this side of the equal sign.
So
So we can't transpose. There isn't even an equal sign here.
Sir, I have a question. Since like both the numerator and denominator are fractions, would you just the KCF?
But we have to set it out first. How do we set it out?
22 over 15 divided by 12 over 5.
Exactly, because the fraction bar here tells us that we're dividing. So it's 22 over 15 divided by 12 over 5. So 22 over 15 divided by 12 over 5. Is that clear?
Yes, sir.
So now, once we have it laid out like this, we can do our keep change flip. So 22 over 15 times 5 over 12. There are things we can cancel. So 5 into itself, 5 into 15, 2 into 12, 2 into 22. So our final answer would be 11 over 18. And that would be your... So a question like this is just 2 marks. I'm not sure how they allocate the marks for this. Maybe they would give you half marks. So half mark for converting to improper, another half mark for evaluating the numerator, another half mark for setting out this, and another half mark over there. So I'm guessing that's how they would do it. Alright, so I'm going to give you 2 more past paper questions, and I'm going to give you 10 minutes to do them. Then we can quickly look at order of operations and wrap up tonight's session. Or we can save order of operations for when we're doing transposition, because that's where it will be used. And transposition and algebra. Let me see. Decimals. Alright, so questions. Alright, so your time is up. So let's hear some answers. Alright, so who's going to walk me through question 1?
So I can do it.
Some of the times I think the person like because it's me when get the pay, but then now listen to the
For
part.
question
You have something
1,
playing in the background, Tori.
sorry,
Just focus on sports and never pick up one story.
So you can hear me better?
Yes, I can.
Okay. So first I worked out the equation in the bracket. So I converted the 4 and 1 over 3 into an improper fraction, which is 13 over 3, and the 1 and 2 over 5, which would give me 7 over 5. And then I found the LCM of 3 and 5, which is 15. And 3 into 15 goes 5 times, so I multiply the 13 by 5 and got 65. And 5 into 15 goes 3 times, so I multiply the 7 by 3 and got 21. So when I subtracted them, I got 44 over 15. And then I started to divide it by the 4 over 15. And because when you're dividing, you have to do KCF. So I changed the division symbol to multiplication and flip the 4 over 15, which would give me 44 over 15 times 15 over 4, which would give me 660 divided by 60. And when I simplify it, I got 11.
Then Tori.
So I know someone could have simplified from the 44 over 15 times that, but
Just decide to go all the way around, but the 11 is the
yes,
answer. So did anyone else get that answer?
I made a mistake.
Where was the mistake made, Kai?
So instead of 65, I got 39.
Oh, here. So just ensure that you're writing the correct thing from the question and double check as you go along. Alright, so who is going to walk me through the second question? Let's see who is here. Khadija? Alright, so question 2 is yours.
Okay. Okay, so first I changed the 2 and 1 over 4 into an improper fraction, which is 9 over 4. And I changed the 1 and 3 over 5 into 8 over 5. And then I worked out the numerator first. So I found the lowest common multiple, which is 20. So 4 into 20 is 5. and 9 multiplied by 5 is 45. 5 into 20 is 4, and 8 multiplied by 4 is 32. So when I work out that, I got 13 over 20. So 13 over 20 over 3. And so like I didn't separate them again. So 13 over 20 divided by the division sign over 3 over 1. 3 over 1. And then I flipped the 3 over 1 and made it 1 over 3 and multiply by 13 over 20. And I got 13 over 60.
Alright, so did anyone else get this answer? So this is indeed the answer. Alright, very good. So as mentioned, I'm going to start off with order of operations. I'm just going to give you the general outline of it, and then for the next session we'll continue on that. So order, this will go straight into decimals and then transpositions next session.
Sorry, when is the next session?
Next week, Monday again.
Okay, sir.
So I'm going to prepare some questions on fractions, some past paper type questions, and just give you those to practice in the meantime. Alright, so for order of operations, what's the one you know?
BOMDAS.
Because we have BOMDAS, BEMDAS, PEMDAS, all kind of crazy stuff.
So I don't know any.
How?
Distributive law.
Distributive law, that would be a, how would I call that now? Just a property of multiplication per se, arithmetic property.
Yes, sir.
So the distributive law wouldn't really classify as one of these. Alright, so for the order of operations, we have PEMDAS. So this is way more than what we wanted. Alright, so it is PEMDAS. And who can tell me what the P means? What the P stand for here? What does the P mean? Alright, so no takers. Parentheses or brackets. I know brackets isn't, so that's how we would get the BEMDAS if we had brackets. What does the E mean?
Equal.
Exponents.
Exponents. The M.
Multiplication.
The A. think somebody else said division. So the D, division, and the S would mean what?
Subtraction.
Alright, so here's the thing. Multiplication and division, these are on the same level. So it's not like we're going to do the multiplication before the division. We just do whichever one comes first. So if the division comes first, we do it. If the multiplication comes first, we do it. So these two are on the same level. Similarly, these two are on the same level. And we would be going from top to bottom. So we'd start up here. We would do the parentheses or the brackets first, then we'd come down to the exponents, multiplication, division, addition, and subtraction, and so on. So a quick example. Let's say we have 4 plus 7 times 3 minus 6. What do we do first?
7 times 3.
So we do this part first. So it's 4 plus 7 times 3
21.
minus 6. So now once we're at this point, we can do whichever one we choose, because we have addition and subtraction, and remember I said that these are on the same level. So we can say 21 subtract 6 if we want, and then we add the 4. We can say 4 plus 21 if we want, and then we subtract the 26. Either way, we're going to get the same answer, whichever one we take first, because both of these are on the same level, addition and the subtraction. So this is 4 plus 21, 25 minus 6, and that's 19. Alright, let's do another example. One last example before we wrap up. 9 times 8 minus 3 plus 7. What do we do here now?
You do the bracket first. So the 8 minus 3 first.
So we have to do the bracket first. So even though we have a multiplication and then we have a subtraction and addition, we have to do the bracket first because of the order of operation. So starting at the top, coming down, the brackets would be the one that we focus on first. So we look at the question, realize that we have a bracket here, so we have to evaluate what's in the bracket. So it's going to be 9 times, when we evaluate what's in the bracket, 8 minus 3,
5.
yes,
So 7.
Because I did.
and then what do we do next? Do we add these first then multiply?
No, sir, multiply first, then add.
Because the order of operation, multiplication comes before addition. So 9 times 5,
45.
plus 7, and that's 52. Is that clear?